Okay, so let's build upon what we've been learning, how to make a calculator. So because this is a new lesson, let's go ahead and increment the version to 1.1. So now we have PyCalculator 1.1. Let's clean this code up a little bit. So what operation would you like to perform? And then we determine if we gave it some input, and then if we didn't give it some input, we print that it wasn't specified, and that should be good. Else, it says the current operation is whatever we inputted. So let's go ahead and run this and see what we get. What operation would you like to perform? I hit enter and it blows up. That's the end of the application. It has nothing else to do. So let's try this again. What operation would you like to perform? I would like to add. The current operation is plus, but again, we've hit the end of our application, so we can't really do much more with it. So let's actually make this do something. So this is a perfect example of how to use a subroutine again to clean this up, because this little chunk right here, this entire chunk, we shouldn't have. We can reformat it, refactor it is the actual term for it. We can refactor it to be a little bit more streamlined. So to begin with, we'll have a new subroutine called choose operation. That's pretty good. So choose operation is going to be, I said subroutine. Notice I said subroutine and not function. So this is a very good example. If you recall earlier on, I created this current operation variable up here. I'm going to recreate it up here so that it's globally scoped, meaning it's accessible from anywhere. So when I stick it in the subroutine, I can still reach it. So again, this seems really complicated, but we'll go over it once I am done refactoring it. So what did I just do here? So I took all that code and I stuck it in a subroutine. What does that do when I hit play? Well, let's see. Nothing. It just writes that one line of code. We never actually use that subroutine. So let's choose that subroutine, or let's call that subroutine. So boom. Now what does it do? Run. What operation would you like to? Oh well, holy cow! It's starting to come together. Well, I would like to perform the plus operation. The current operation is plus, and now we're done. So now, basically, if we want to look how this is what it looks like in the actual runtime, or rather, this is what gets executed at runtime. The reason this is important is we want to be able to basically we don't want to be overwhelmed by code. That's why we're able to collapse these functions, because once a function works, in theory, unless you want to refactor it, make it work better, we never need to touch it again. We don't need to know what happens inside this function because it just works. So let's take a look at this again. And so what operation would you like to perform? And I'm just going to start doing some is add. So now we want to determine where this goes. So we got a little idiosyncrasy to take care of when it comes to global variables. So I call this a global variable, and it is, but I haven't been using it correctly. Let me give you the example right off the internet. Python global variable example. So again, this is an idiosyncrasy that is only in Python. Basically, if you want to use a global variable, you need to you need to call it out at the start of the function. Why? I don't know. That's just how it is. So basically, you want to call it out at the start of the function so that you can get its scope. Basically, let it know that you're working with the global version of a variable instead of the local version. Meaning, if I want to use this current operation, I want to tell them that I want to use this current operation, global current operation. It looks weird. It makes no sense. It doesn't look good, but it is the way this programming language works. I know of no other language that does it this way, but that's how it works. That's how they decided this works. So just to clarify this, I'm going to put a little comment afterwards. I'm going to say correlates to global variable. So why is that important? It's because this takes place in its own little subroutine, its own little universe. So unless I put this global keyword, this current operation is only going to be a local variable called current operation. It's not going to be this variable here, which is accessible anywhere. It's going to be a variable that only exists here. And if it only exists within this choose operation subroutine, it's not very useful to me. I want to be able to know what the current operation is anywhere in the application. So just to give you an example of the fact that it's working properly, I'm going to print out what it does afterwards. So now we can see that it welcomes the user, it makes them choose an operation, and then we're going to print out what that operation is. So this right here actually becomes redundant because we don't want any of this stuff here. We just want yeah, that's more than we need right now. So let's simplify this, and I'm going to stick this. I'm going to stick this someplace else just for reference. I don't want to lose my code right now, so I'm going to stick it right over there. I know I said recoding something makes you a better coder, but I want to spin through this as quickly as possible. So we are going to take that current operation and we'll fire it off. So let's see what it does now. With copy raising, I'm going to say plus. Plus is plus. It actually prints out. So it actually does the same thing as ever. So now we're able to actually use this beforehand. So how is this useful to anyone? So choose operation, this determines the operation, and then we have that operation assigned to this current operation. Wow, that was horribly worded. Let me say that again. It fires the choose operation command function, takes input, and assigns it to current operation. So let's just call this start, because this is getting weird. So start. And you know what? Since it is start, I'm going to also put the welcome message in there. So now, when we fire start, all it does is prints the message. Well, that's redundant. It basically says exactly what it does in code. And then it receives the input and assigns it to this globally accessible variable called current operation. So now, basically, the entire application has been broken down into this one line of code. Start. What operation? Add. And that's all it does. So we need to make it do more now. So thankfully, we have access to this current operation variable. Let's call it action. That's not bad. So action, action, action. So now we have the action that this is going to be assigned to. So we can start to use conditionals to figure out how we're going to route this data. So if action is equal, and that's a little nuance right there. There's assignment and there's is equal. Is equal is when you're asking the question. So I could say x equals 1, but when I'm asking if x is equal to 1, again, it's just a nuance. This is pretty much used ubiquitously throughout all computer programming languages. So the way you can remember it is this is the assignment, and when it's two equal signs, it's is equal. So that's kind of the way you can say it, is equal. Is equal equal. Equal equal equals is equal. So what I want to do basically is determine what operation I want the user to, or what function I want to route to based on what operation they chose. I'm going to say that again. I want to determine what function they route to based on which operation they choose. So we got to determine what operation they chose. And now that I'm using operation so much, I'm going to go back. Operation. Operation, operation, operation. So if the operation they chose is equal to plus sign, then it does this. And I'm going to say print A. And now we have a new conditional else if. So we have if and else, but that's only two paths. You want to be able to have as many paths as you want. So you want else if. You can have as many else ifs as you want. So if operation equals to negative, we want to do the other thing. So B. So right now we're only allowing the user, after they've run the start method, to assign the only two valid inputs is a plus sign and a minus sign. So let's see if this works. So we run it, and syntax error equals at the negative if on line 32. What happened here? Else if, oh, boom, colon. We forgot that. Notice that it gave you a completely nonsensical location. So you have to be able to basically read between the lines, and I think I've said that already. So we run it now, and it still has an issue. So else if. So maybe it's different. I think Python else if example. Maybe it's one word in Python. Elif. Well, isn't that needlessly confusing? Fine. Elif is the word. So else if, as it's used everywhere else, is called elif. So run it, and we're back in business. So I know a plus sign should be valid. So that's what operation are you going to perform? Takes in the input, assigns it to the operation. If the operation is a plus sign, it should print A. So if I hit enter here, it says A. So we've got it working the way we want it, but it doesn't actually do anything. So what we actually want to do is enhance this further and actually write the logic. So yeah, let's just continue on here. We'll break it down here. So what we want to do, the next thing we want to do is, and it would go back to where we were and get some input. So we have well, let's just use x and y. So again, this is a question of scope. These parameters have the scope between 11 and 12 and 15 and 16. So we can reuse them because their scope only exists in this very small area. Now I'm going to use their scope here. This is going to become scoped to just between line 30 and 32. Or basically within this statement itself. If I define it up here, x equals 0 and y equals 0, those become global variables, which again we have to deal with this global operation. But I don't need to overcomplicate it right here. So let's just figure it out, or let's just use it locally so we can get this thing going. So x equals input. And we'll say input 1, enter a number, colon, and remember it looks weird unless we put I used the wrong one. That's probably why they have the different coloration, just so we don't make that mistake. And then y equals enter another number. And now we have x and y, and then we can actually use our function to add them together. So we say result equals add x and y, and we have the basis of the addition portion. Now we can just do the same thing right here. And again, it's very important that we get these tabs correctly, otherwise it doesn't work. Enter number, subtract. And so now we have basically a partially working calculator, hopefully. So what does this do? Well, again, we can talk about it all day, or we can actually just run it, see if it works. What operation would you like to perform? I would like to add something, please. What would you like to add? 5 and 10. So what do I get? Nothing. What happened? Oh yeah, that's right, I didn't do anything with the variable. So I want to print result. Print result, print result. So let's fire it again. What operation? I want to add something. What do you want to do? I want to add 5 and 10 together, which gives me 15. Amazing. So let's stop right there, and we'll clean it up in the next lesson.